Hello and welcome back to Mr. Lamb's Science Corner. Today is another kind of a little bit of a strange one. We're going to talk about math and not do a demonstration, but this is somebody that you may very well, depends upon where you are in terms of this. If you talk about prime numbers, this would certainly fit in with that conversation really well. I'm going to demonstrate to you something called the Sieve of Erastothenes. And I know that's quite a mouthful there, Erastothenes. I'm holding it up here for a while so you can get the spelling on it correctly because it's not easy. He was born 276 BCE and died 194 BCE, so he lived a good long time. Of course, the numbers count backwards because it's before. Now, a lot of times you'll see BC, and many people think it's before Christ. And they say AD is after death. And that ignores the whole lifetime of Jesus and what is set there. So, and we have the serious problem of, if you take a look at the world's population, there's a whole lot of people that are not Christian. We'll just say it that way. And maybe you have some in your classroom, or you don't, whichever. It doesn't really matter. But AD actually stands for Anno Domini, which is Latin for in the year of our Lord. And there are people out there who say, no, it's not my Lord. So they resist saying, you could say, well, it's politically correct and all like that, and guilty, I guess. But if you can, start saying BCE, which stands for before Common Era, and then you'll also see, instead of AD, you'll see CE, which stands for Common Era, which means that pretty much around the world, regardless of religion, people agree that this is the year 2018, soon to be 2019. But in the Jewish tradition, it's a much different date, and in the Hindu tradition, and in the Muslim tradition, and if you want to talk about people I'm quite sure the Wiccans count differently, and the Zoroastrians and the Mithraists, and the Confucianism and Buddhism, and you just get into a lot of trouble. So if you talk about before Common Era and Common Era, you'll avoid all that. So anyway, so if you see BCE, plus it makes for a good discussion during the classroom. So Erastothenes is the person we're going to talk about today. And he is the guy who discovered the circumference of the earth. And it was his discussion that basically said, because a lot of times we get the idea that Columbus convinced the king and queen of Spain that the earth was round. They knew that already. Every educated person knew that the world was round. They weren't going to fall off the edge of the earth. What Columbus screwed up in, and he was a lucky person, what he screwed up in is that if he had used the best accepted value that Erastothenes came up with, as you saw, way back when, he never would have taken off, because the distance from Spain to China or India was way too far. They couldn't carry enough water and food. He lucked out that there was the New World there. And as it was a pretty close thing anyway. He used a different value for how they converted from one unit to another. So if you talk about conversions and the kids say, why do we do conversions? Well, sometimes it's life and death. And as it was might have been in Columbus time if he hadn't been so lucky. So he used a smaller value, and he said the Earth was smaller. It's not. Uh, so anyway, so he came up with the circumference of the Earth, and he also, amazingly enough, as I found out by doing this, is he invented geography. So if the kids are, if they really like geography, he said, well, hey, here's somebody that you should probably know more about. Erastothenes would make a great subject for papers. He also calculated the tilt of the Earth. The Earth is not straight up, it's tilted, which is why the sun moves from north to south as well as east to west. So, we have in the wintertime the sun is lower in the sky, and summertime it's higher in the sky, and every once in a while it's straight overhead if you are towards the equator. He came up with the idea of what the tilt is, 23.5 degrees. He may have, and the source I had wasn't sure, just calculate the distance from the Earth to the sun, which would really be quite amazing considering when he did this. He also came up with the first person to come up with scientific chronology, and basically things happened at certain times, and he based it on the fall of Troy. So he said, before Troy this happened, after Troy this happened. And so he came up with the idea that we can get some kind of idea of when things happened. And then divide the Earth into 5 temperature zones. He said there's 2 polar regions, there's 2 temperate regions, and there's 1 tropical region. And that's what we do today. Think about it, if you're living in the United States, you're living in the temperate zone. It's not, it may seem tropical by the time you get down to Brownsville, Texas, and if you get into Minot, North Dakota, you may very well think you're in the polar region, especially wintertime. The sieve is to find prime numbers. And I very carefully, there we go. So, if you want to find the prime numbers from 1 to 100, one way of doing it is doing a sieve. Now a sieve, I couldn't find an actual sieve, but I found a colander which kind of acts like a sieve of one size opening. If you were to put a bunch of stuff into this colander, anything smaller than the holes would fall through, and anything larger would stay. So if you're cooking noodles, you have to kind of rinse them off, and so the water will go right through and the noodles will stay behind. A sieve actually has different layers of different size. So if for example, if you're making gravel, so you take and you break up a bunch of rock and you put it into a sieve, and the really large rocks stay in the top, and everything else falls through, and then some stay on that level as you're shaking it around, and so it separates. And I know that I've done various projects around the house, and there's 2 different sizes that I use. One is 3/4 clean, so it's sieved out to give me 3/4 inch gravel, and only 3/4 inch gravel. Or sometimes it's a little cheaper and sometimes it's a little better to buy 3/4 minus, which is everything from 3/4 inch and smaller. So it depends on where you set the sieve as to what you actually get. So what we've got here is I typed up, and it took some time to do this. I'm not gonna lie about that, but once you do it, make copies and make an overhead. Okay, so you can make an overhead of this, And then the first prime number that we have is 2. Okay? So 2 is a prime number. So I'm going to circle it. And then I can mark, now anything that's a multiple of 2 cannot be a prime number, because a prime number has 2 factors, 1 in the number itself. So 2 is 2 times 1, that's 2 factors. 4 has factors 1, 2, and 4, so it's not prime. So 4 and 6 and 8 and 10, all those out. So I'm just going to go and I'm going to wipe out. So now I've wiped out all the multiples of 2. Well, the next number, 3, is a prime number. And 6, this one's a little trickier. 6 is a multiple of, of 3. 1, 2 times 3, so it's not a prime number, but it's already checked out. But 9 hasn't been. So I can go through and mark out 11 is not a multiple of 3, 13 is not a multiple of 3, but 15 is. The way I know multiples of 3, add the digits. If it's divisible by 3, the number is a multiple. Now I use some abbreviations, but we add the digits. So 9 is just 9, and we know that 9 is a multiple of 3. 15, 1 plus 5 equals 6, and we know that that is a multiple. And I know that a lot of you, I'm telling you, not new stuff, but some of you maybe don't know all the details. And especially if you're a parent out there, it may be a while since you've been, since you've had to do this in school. So trying to explain to your student is kind of exciting. So we can add the digits together. And so we can mark out all these, and I'm not going to mark out all of them, but 21 is 2 plus 1. 21 is 2 plus 1, and so on. 5, multiples of 5, does it end in 5 or does it end in 0? If it ends in 0, we've already marked them out. If it ends in 5, we'll just take out that whole column. And so 5 is a prime number. 7 is a prime number. There is an equation for 7, but quite frankly, I don't remember what the equation is. I've used it before. I hate it. If you want to find it, you got to be able to Google and find it fairly easily, and you'll find that you probably hate the equation too. So, but basically, we can do this sieve. We're sieving out all the multiples of 2, sieving out all the multiples of 3, all the multiples of 5, 7. And it turns out that that's as far as you need to go for the numbers 1 through 100. That this will find all the prime numbers from 1 to 100. And I don't have my list here. I wrote it down, but 11 and 13 are certainly prime numbers. 17, 19, 23, 29, 33. I kind of like that 67 is a prime number because that's how old I am, and I tell people that I am in the prime of my life. And next year when I turn 68, I won't be in the prime of my life anymore. But if I make it to 71, I'll be back into the prime of my life. I'll say that with a smile. So Anyway, what I'd like you to take away from this is that Erastothenes is a very interesting gentleman, very worthy of finding more about him. The sieve is kind of fun to do. You can take it if you want to go 1 to 1,000. You can do the same process. You're going to have to go a little further than just 7. You're going to have to find out what are multiples of 13, for example, which has got to be ugly. So have fun with this. Like I said, all you need to go is 2, 3, 5, and 7. We'll find all the prime numbers from 1 to 100. If you want to go any further than that, you certainly may do using the same process, the same sieve. Thank you very much.